Good morning, on and all present here. I am Nandhini, working as an assistant professor in Department of Computer Science and Technology. Today we are going to see a topic on physical design of an IoT. What is the physical design of an IoT? The things in IoT usually refers to IoT devices which have uniquely identifiers and can be performing remote sensing operation, actuators and monitoring capabilities. IoT have an exchange data to other connected devices and application which is used as a directly communicated or indirectly communicated. Collect the data from other devices, process the data locally or send the data to a centralized server. So the cloud-based application has an end-to-end performance. The device has an wired and wireless both performance. It includes IoT interfaces for sensors, interfaces for internet connectivity. For example, connectivity consists of USB host, RJ45 or Ethernet. Processor consists of CPU, audio and video interfaces, HDMI, 3.5 audio, RCA video, memory interfaces, NAND and NOR gate, DDR1, DDR2 and DDR3. Processor CPU, graphics CPU, and the storage interfaces SD, MMC, SDIO. IO interfaces consist of UART, SPI, I2C, CAN. In the physical design of an IoT, we are going to see that the IoT protocol links the layer with the help of 802.3, which is known as an Ethernet, and next is 8.2.11 Wi-Fi, 8.2.16 is WiMAX, 802.15.4 is LRWPAN, 2G, 3G and 4G are being used in the network or internet layer. Internet protocol version 4, Internet protocol version 6, 6 LOWPAN, transport layer, TCP UDP, in application layer, HTTP, COAP, WebSocket, MQTT, XMPP, DDS and AMQP are being used. The IoT protocol links 802.3 Ethernet is a wired standard, 802.3 is a 10 base 5 coaxial cable, 802.3i is 10 base T twisted pair, is 802.3j is 10 base F fiber connections, 802.3AE 10 gigabyte Ethernet fiber connections. In Wi-Fi LAN, 802.11a 5GH, 802.11b, 802.11n, 802.11ac 5GH Z, 1 Mbps to 6.75 Gbps, 802.16 is WiMAX, wireless worldwide interoperability for microwave access wireless WAN, 1.5 Mbps to 1 Gbs, 802.16 1A, 802.16 etc. In the WAN, low rate WPAN 40 kbs to 250 kbs, suitable for low cost, low rate. 2 GB, 3 GB and 4 GB with 2 GB is 384 kbps, 3 GB 2 Mbps and 4 GB is 100 Mbps. Network layer or internet layer protocol. Network layer are responsible for sending of IP datagrams from the source network to the destination network. IPv4, low address space with 2 power 32 address space is 32-bit addresses. An IPv6, larger address space with 2 power 128 address space with 128-bit addresses. 6 LOWPAN, IPv6 over low powered wired person area network, low power device which have limited processing capabilities. Transport layer protocol provides end-to-end messages transfer capability independent to the underlying network. TCP, connection oriented, reliable oriented order of delivery, retransmission and duplicate avoidance. UDP, connectionless, unreliable, no order of delivery and transmission, packet loss. In a physical design of an IoT, in an application layer, it consists of hypertext transfer protocol, constraint application protocol, WebSocket is duplicate communication, message queuing telemetry transport protocol, a public subscribable model, XML messaging and presence protocol for real-time communication, data distributed system for device-to-device communication, advanced message queuing protocols have been used because why these protocols have been used is this duplicate communication over a single socket is used to send the message to the client and receive the message from the server. In the message queuing protocol, one public subscriber model is being used. This XML streams data between network entities and other devices. Machine-to-machine communication and device-to-device communication have been used in an earlier phase of these protocols, because this application layer is a main layer which uses to have a web browsers with basis for www and the constraint protocol to machine user UDPs, etc. This advanced message processing queuing protocols have been a very important one. Thank you so much for the video.